Hi, welcome back to hostboxcse channel and back to the tutorial for artificial intelligence. This is a tutorial definitely helpful for who are learning and preparing for UGC NET college level competitive exam also. Today we are going to continue the topic called genetic algorithm in artificial intelligence. The previous session I explained about the supervised learning and unsupervised learning with real time example. Please kindly check the playlist for more updates and support our channel. Let's see the genetic algorithm in artificial intelligence with a real time example. So genetic algorithm is one of the very important area and in the field of machine learning. It definitely helps for a lot of applications today and automobile robotics and so on. Let's see what are genetic algorithms. So generally we can say some of the points here. These are search-based algorithms based on the concept of natural selection and genetics here. And these are also a subset of larger branch of computation known as evolutionary computation. So genetic algorithms are one of the algorithm always based on the concept of little bit biology. Some of them or many of them study with biology where you have discovered the chromosome, genes and so on. So there are some similarities between these genetic algorithms and this one. And before now these algorithms and what are the steps involved in this one and what are the points are important, we have to know the some of the basic terminologies used in the genetic algorithms. That is called population, another called genotype, another called phenotype, and another one called fitness function. So what is population? So in the terms of computer science and in terms of artificial intelligence and also in terms of genetic algorithms, you can say it is a subset of all possible solutions to the given problem. So why we go for this genetic algorithm? Because of get the optimal solution, perfect or best solution for the given problem, any complex problem. You know already a variety of algorithms and methods are so many technologies to get a solution, but even though genetic algorithms provide the optimal solution here. And genotype, what is genotype? It's a population in the computer space, and also in the computer space the solutions are represented in a way which can be easily understood and manipulated using the computing system. And also phenotype. Phenotype is the population in the real world solution space in which solutions are represented in a way they are represented in the real world situations. And fitness function, very important. What is fitness function? It's a important two more question also. Is as a, can say it's a function which takes a solution as an input and produces the suitability of the solution as the output here. So let's going for another important point. So we go for another mode where you have a diagram and I explain again the encoding decoding here. Is the you may study in the networking, don't get confusion here. This is purely artificial intelligence. Let's go for here. So the general diagram for phenotype space and genotype space. Here we can say what is decoding. In the point of view, you can say it's a process of transferring a solution from the genotype to the phenotype space. Or what is my encoding? When encoding is important, that is a process of transferring from the phenotype to the genotype space. Here, what happens means, let's assume that you have a such problem like travel search management. Here, the raw data and the information should be in a such space in somewhere in a manner, but it's not ordered. So if you want to find a solution, we need the help of encoding. So genotype means what? The conversion of the information is the useful one and needful way. So if you make some computation everything in the problem in some manner, so after the stage of genotype you can solve easily. That's means raw data, raw information, what is it? It will convert to the structure where in the form of genotype where you can easily solve the given problem. Then back to the PPT. Now what are the important points of we'll consider these genetic algorithms. So a lot of things is there. I'm saying very important points here. First one, abstraction of biological evaluation. So when you go to find the solution for the given problem, it's almost just now I told you chromosome, genes, some of the already some problem for solution defined, from there we can same problem we can take and find the another way of solution, and also let's provide the optimal solution here and solve complex problem. You can solve a travel sales problem or any complex problem you can solve with the help of generic algorithms, and focus on optimization. Yeah, optimization in the sense what we already know. Generally algorithms, you may apply the algorithm concept in this participant intelligence will get the solution, but there is no guarantee. So whenever you go for this one, you can focus on optimization, that means guarantee and best solution we can get it. And next one is find is population of possible solution for a given solution. So here whenever go for finding the possible solution for a given problem, not solution. So whenever any problem you can get solutions, and from there you can select it. You can give different inputs and different outputs, you can get it, and from a group of individuals the best will be surveyed here. So I told you any problem you can make from the basics of biological evaluation. We can have generic algorithm. Already have parent, best parent is there. We can select the parents. With the help of two parents, we can two best parents. You can create a child, and also after that you can generate the solutions here. And steps. What are the steps involved in this generic algorithm? There are six steps there. One is called initialization, another one is called calculate fitness, another one called selection, another one called crossover, another one called the mutation. At last we have stopping criteria. So whenever find the solution, yes, we can stop and we can consider this a optimal solution. Otherwise, no, we can go back. So before going, first of all, you know the initialization. I'm saying the best real-time example here, diversity. So initialization means what? Diversity. What kind of diversity you are going to do? For let's say, take the example of exit poll. Here, what will focus here? Focus on particular age group. We always focus on the particular age group. So particularly we can make lot of diversions. Some such spaces there, diversion of more than 18 years we target the poll here, under 18 years and some age group we can make lot of here, and after that we can go for fitness and so on. And let's go for another points, and before going we go for another mode where we get the clarity. So I go to the paint mode where you have a clarity here. So next is calculate fitness. So calculate fitness is the very important step when you consider this area of generic algorithms. You see one by one with a simple example here. So calculate fitness will be there, and calculate business I say the some real example here. You can easily get it. So it's a new term when I come to the generic algorithm. So here let's take the example of I'm having a 4-digit word here, that is make. So when a 4-digit word make, what happen means we can I want to make the word called make, but same time I have one more word called take. So now how do you find the input fitness value here? So let's compare both. So if we compare both, T is not there but A is there and K is there and E is there. So we can find and say the input fitness value is 3. Simple and easy. So whenever for a generic algorithm, any problem you can stop. First step the initialization, where we have population search space for the based on the problem. After that you can go for the second step called fitness value, calculate the fitness value. Then moreover I have one more, I'm taking one more word ABCD, and one more word I have K, one more word ABCD. So from the make, how can I make compare means when you compare this both word, which is common? A is common, BC is DD is not BCD is not common. So we can finalize the fitness value is 1. So we can't take, this is our solution for the given problem. Let's take another example, cake. When you cake, so what is there 1? C is different but A is there, K is there 1 and E is there 1. So totally 3 letters will be there. So we can select and say the input value is 3 here. And its next one is, and we'll go for another mode where we have a very important one. Next the flowchart also seen. So this is a selection. So selection is a very important one where we are going to select for any given problem we are going to select the solution based on this one only. There are 3 major steps involved in this generic algorithm, very important. That is called a selection, another one crossover, another one called mutation. So first one the selection. So which based on the given inputs and generating output, we have to select which method is good for you, which method is suitable for your relevant output, whether possible to generate the as much possible here the output will be relevant to the input. So what kind of your expectation, it should be solved here. Let's back to PPT here. So here So selection is very important. We can get it easily. Let's say if I say ABCD, what happen means it's not matching. So we can consider either take or cake is the relevant output for the given example here. Let's take very next one is crossover. So crossover means we can go deeply. We have multi-over, crossover, and lot of method is there. We are following the method one, that is method point one. If we take the method one, we can consider this example here. Simple example. Let's consider the letters I have ABC, and after that D is there, and another letter I have EFG, after that letters I have HI. So what happened means crossover, just to swap the letters, remember. So whenever crossover here, lot of method is there, swap, bit leap, bit flip, and so on. We are following only swap just for another understanding. This is a method point one method. So here what happened means, if you cross swap the values, what you can ABCE, after you can HI, and after EFG you can write DE. So we can write swap or crossover. This is a simple example for understanding the crossover method. At last, now the question is, as per diagram flowchart, what is there here? Mutation and stopping. Mutation means what? Mutation nothing but where we are considering, we are going to have different, here we will get different populations. What are the different population with the different output? We are always going to get the better solution. Optimal solution as a better solution. Suppose that is called stopping criteria. So stopping criteria sense, you can say that's considered, you can say convergence, or you can say end point. So once you got the solution for the given problem, best solution, you can stop the solution. Or else if no, again go and again search and get the calculate the fitness value and select the best one, and after go for crossover and come to the mutation. At last consider and take the solution here. Let's come to the final zone. So now what is the final output for the given problem? So if you want final output for the calculation, so and remember the input fitness value always should be higher than output, higher than in the given problem. So here let's take again take the concept of make here, and here I am writing final value, that is a final output. So how can I make crossover here? AKME I can write, and I can write another method KME. So what is the fitness value here? 4, and here also fitness value 4. So when you go for the solution for the given problem, we can consider this final output value and take it as final. So these are the points. So what are the steps? Why is so much important? And the diagram, and what are the steps in the generic algorithm? These are the points very important for the college level, competitive level, and UGC exam also. If I any queries or suggestions, please kindly communicate with the social media. And thanks for watching. Please like, share, comment, subscribe, press bell icon for more updates. Thank you.